Hello, James Flaten here with the Minnesota Space Grant. I'd like to talk for a few minutes about using epoxy on rockets, and in particular, trying to epoxy the fin can, which is maybe the most challenging of the various epoxy jobs you might do when you're building a high-power rocket or a model rocket. So first of all, let me switch to a work surface here and pull out a model rocket. So here's a model rocket, and this is the fin can. On this particular model, the fin can, here's one that hasn't been built yet, already has the fins attached. So that's simple. But if you are to attach the fins yourself, you have to simultaneously do three things. One, you need to make sure that the fins are well aligned with the body of the rocket. Second, you need to make sure that the fins are perpendicular or run radial to the body of the rocket. And third, you need to make sure that the fins are equally spaced. You need to do all three of those things at the same time. So this one, where it's pre-printed, is very easy, but let's see how you might approach this task, at least for some practice materials. So here's a piece of tubing. This is actually for model rocketry. And here's a little piece of wood. I'm going to call that my fin. So if I want to attach this, I'll use the word glue to just mean the verb to attach things with either single component glue or a dual component epoxy. So if I want to glue the fin to the piece of tubing, typically this would be a long piece of tubing and I would be gluing close to the bottom of it. Well, one of the first things I want to do is I want to draw a line along the side of the airframe so that I at least know that my fin is running parallel to the rocket body. I'm going to use a piece of angle, it's not iron, I guess, angle aluminum. And if I just literally set that onto the airframe, it holds the direction. And so I can mark it. There we go. So that's part of the battle, to make sure that my fin is going to run exactly along the axis of the rocket. The second part of the battle is to make sure that when I glue it on, it runs radial. And so what I've done is I've already marked on my surface here, my work surface, some radials. And so if I orient that line I just drew along this particular radial, now I can simultaneously get the fin running along the length of the rocket and exactly radial. So that's two of three. I'll talk about the third one separately. So for gluing this on, what I'd like to do is I'd like to use super glue for starters. This is not strong enough for my ultimate bond, but this will get me going. So I'm just going to put some super glue right along the root of the fin. So this will be called a butt joint. Put a little bit more super glue on because it's kind of soaking in. Set on my template, set my fin on my template, set my airframe on my template, squeeze them together. For this particular super glue, I need to keep them together for 15 seconds or so. So again, with this particular set of tools and workspace, I'm able to get my fin to line up with the length of the rocket and also to be radial, if I'm careful. There it is. You'll notice that I'm working on some parchment paper, could be wax paper, to try and keep this object from sticking to the surface while it's dry. Looks like I could have possibly shifted the tail end slightly that way, but anyway, good enough for now. Let's talk a little bit about how you might get 4 or 3 or 7 fins equally spaced around the circumference. Here's another piece of tubing, and what I've done with this piece of tubing is I've wrapped a piece of tape around it, and I intentionally made the tape not quite line up when it came around, and so then I made a mark, and that mark goes onto the upper piece of tape and the piece of tape that's below it, so that when I unroll the tape, then I can measure out. It turned out to be 13 centimeters, and then I just divided 13 centimeters in this case by 4, and so I went 3.5 centimeters, 6 centimeters, 9.5 centimeters, 13 centimeters. And I was able to mark, assuming that I wanted 4 fins. And then now I can put it back on, put the tape back on, and then I can go ahead and actually mark my airframe. So there's one. I'm still using this device, which helps me draw things that are exactly aligned up. It's angle iron, angle aluminum. Okay, so there I have it. And I could potentially put the fins on and they would be evenly spaced. Here is not the one I just did. This one has actually been drying for a little bit longer. But I'd like to show you how I can make that a stronger joint. So it turns out that super glue, although it dries very quickly, is not, and glues in general are not that strong. I want to use a 2-component epoxy, and I've already mixed some up. So I have some epoxy ready to go. And yes, I mixed it up just before starting this video, and it's still okay. This epoxy is called Aeropoxy, and it takes maybe 20, 30 minutes before it can't be used anymore, so I still have time to use it. What I'd like to do is I'd like to put some epoxy right in this groove, and I might do the other side too. This is called a fin fillet or an epoxy fillet. And what it will do is it will allow the airframe, which I should have scuffed up to make sure my epoxy sticks better, and the fin, which I should scuff up also, actually have extra contact surfaces. So I'm going to try the following. I'm going to try to put a fin fillet on this side, right in this groove. And, you know, this is making it stronger for sure, but it turns out that it's very hard to do this neatly. Okay, so continuing along. So I'd say that's a not very neat fin fillet, but it's usable, it's workable. Okay. Here's an approach that can make a significantly neater, not necessarily stronger, I suppose, but significantly neater fin fillet. I'm going to use some masking tape, and I'm going to mask off the places that I don't want the epoxy to go. So I'm going to lay down the masking tape about 2, maybe 3 millimeters away from the fin on the airframe side. And the second piece of tape, I'm going to mask off the fin away from the airframe. Again, 2, maybe 3 millimeters. What this does now is it gives me a place where I want the epoxy to go, and frankly, a place that I don't want epoxy to go. You'll notice I'm not wearing gloves. I probably should have been, because I just got some epoxy on my fingers, but that's okay. Here comes the epoxy. I'm going to apply it exactly the same as before, which again, kind of looks like a mess at first. I'm using a curved stick, and so the curves of the stick can actually form the curve of the fillet. So that's nice. And now here's the most important step. You need to remove the tape while the epoxy is still wet. There we go. One piece off. Second piece off. Much nicer than that one. Okay. So now it's time for this to dry. And if the stuff is runny, then you probably want to dry it laying horizontal so that gravity helps keep your epoxy in the groove. It's easier typically to let it sit vertically, but again, if it's runny, then it might run down and pool on the bottom. So this particular epoxy is not very runny, and so I could probably get away with letting it dry this way. But if I have the time, I would be inclined to put in this fillet, let it dry, and then put in this fillet, let it dry, and then one at a time, or perhaps 2 at a time. If I do 2 at a time, don't do the 2 that are on either side of the same fin, but rather there's going to be another fin here. And so what I could do is I could put in this fillet and let it dry just like that, because gravity will hold both of them in place. And then I could rotate it and do this fillet and this fillet. So 2 adjacent fillets, not 2 fillets that are on the same either side of one fin, but 2 fillets that are adjacent on adjacent fins. Anyway, some ideas for applying epoxy and for building a fin cam.